Okay, let's have a look at a couple of more examples. If we have a look at this function here, again, it's an exponential with a base of e, so we just need to differentiate the indice and then bring that down to the front so that dy by dx is equal to the derivative of this. Derivative of 2 is 0, and the derivative of negative a half x is negative a half. So I'll bring the negative a half down to the front and then multiply it by this function here, which is 2e to the 2 minus a half x. And that's our final answer. This next one, before we differentiate, we might need to rewrite this using our fractional indices and negative indices. So let's write it as e to the x. When we're taking the square root, it's the same as raising it to the power of a half. And this would be the same as e to the x to the power of a half. So let's tidy this up a bit. So we've got, this becomes e when we've got brackets. From our index rules that we've done previously, we know that we multiply these indices and we get a half x, plus this would be 1 over e to the half x, but when we bring that to the top, it's going to be e to the negative half x. Okay, and now we differentiate as we have previously. So dy by dx is equal to, differentiate the indice, and that becomes a half times e to the half x, and plus, let's look at this exponential. The indice is negative a half x, so the derivative of this indice is negative a half, so it's negative a half e to the negative a half x. We'll just tidy this little bit up a bit. So we can write this, we could write it, take out the common factor of a half, and then we've got e to the half x minus e to the negative half x, okay? And that's our final answer.